This is Module 10, Section 5.4. In this section, we're going to look at the addition of polynomials and subtraction of polynomials. When adding polynomials, you are simply adding like terms, as before. Remove any grouping symbols first. So really, you've already talked about adding and subtracting polynomials. They're just calling it something different. It's really just a matter of combining like terms. So the first thing you want to do is, if there are any grouping symbols in the expression, you want to remove those grouping symbols by distributing if needed. Now notice that in this first example, we have a single polynomial times a second polynomial. Plus a second polynomial. In order to remove those parentheses, there's really nothing to distribute, and so you can just drop those grouping symbols and have the exact same problem with or without the grouping symbols and not change the essence of the problem. There's nothing out in front to distribute, and since it's addition between the two groups, removing the parentheses doesn't change anything. So now it's just a matter of combining like terms. So we've got a 9y squared and a 12y squared. Remember, when combining like terms, you just add or subtract the coefficients and the variable piece carries along with it. So 9 plus 12 will give us 21 y squareds. Then we've got an 8y minus 5y. Those are like terms. 8 minus 5 is a positive 3y. And we've got minus 4 and plus 8. 8 minus 4 is a plus 4. At this point, check and see that you haven't missed any like terms. Notice that those are all addition operations, and there are not any more like terms to combine. That would be your final answer for that problem. Okay, same thing on this next example. You need to remove the grouping symbols, and since there's nothing to distribute other than an understood positive 1, if you wanted to think of that, but remember, 1 times anything is itself, so you can just remove the parentheses and not change the essence of the problem, as long as you have addition between the groups and no coefficient to distribute. So out front, same thing. We've got 3/8x squared minus 4x minus 2/3 without the parentheses. Now combine like terms. So we have a couple of squared terms. Add the coefficients and the variable piece carries along. So out to the side here, we've got 3/8 plus 1/8. This is just fraction work. When you're adding fractions, you need a common denominator. We have that. So 3 plus 1 is 4/8. And if you reduce that, take a common factor of 4 out, you're left with 1/2. So we've got 1/2 x squareds. Then we've got a couple of x terms. We've got minus 4x plus 7/8 x, so I'll do that off to the side. We've got minus 4 plus 7/8. We're going to make that negative 4 into a fraction because we need a common denominator. So the common denominator here would be 8. We need to build up our fraction. So now we have negative 4 times 8 is negative 32 over 8 plus 7/8. Negative 32 plus 7, 32 minus 7 is 25, but it is negative because the 32 is the negative piece of that problem. And then common denominator of 8. So negative 32 plus 7 is negative 25, and that's negative 25/8. Or minus 25/8, and those are your x-like terms. And then finally, we've got minus 2/3 and plus 8, so I'll do that off to the side as well. Minus 2/3 plus 8 is the same as minus 2/3 plus 8 over 1. We need a common denominator, so let's build up that second fraction, so it also has a denominator of 8. That gives us negative 2/3 plus 24/3. 24 minus 2 is 22/3. Positive, so that's plus 22/3. Now those three are all unlike terms, and because it's subtraction and addition, That would be our final answer for that problem. All right, let's do this decimal piece. Okay, it is a polynomial plus a second polynomial. The reason that the problem put those parentheses in the first place is to indicate to you that this is a polynomial, a trinomial, and you're adding to it this other polynomial, which also happens to be a trinomial. But you don't really need the parentheses, so we're going to take those out. So we've got 0.4a squared minus 0.6ab plus 1.2b squared plus, if we remove those second parentheses, 4.3a squared plus 5ab plus 6.3b squared. Find your like terms. We're going to start with our a squared terms. Okay, we've got 0.4 plus 4.3. So you can do that off to the side, or you can choose to use your calculator to help you, as always. 0.4 and 4.3 is 4.7 a squared. Then we have some AB terms. We have negative 0.6 and positive 5. So again, either off to the side or using your calculator, if you take negative 0.6 and add to it 5, you get positive 4.4 ABs. And then finally, you've got a positive 1.2b squared and a positive 6.3b squared. If you take 1.2 and add to it 6.3, you get positive 7.5 b squared. Those are all unlike terms. You can't combine them because they're being added. And so that is your final answer for that problem. All right, let's look at subtraction then. When subtracting polynomials, you are simply subtracting like terms as before. Remove any grouping symbols first, remembering that the subtraction sign applies to the whole polynomial following it. That's important. Therefore, you need to distribute the subtraction to each term in the second polynomial. And this is from a previous module. We know that when we have a subtraction sign in front of a group, that's the same as adding a negative 1, if you want to think about it like that. So you do need to multiply each term in that group by a negative or negative 1, which is going to change the sign in each of those groups when you remove the parentheses. That's different from addition. With addition, we just dropped the parentheses and all the terms were the same. Now, the first group, which has an understood positive 1 in front of it, you can just rewrite that. Nothing's going to change sign there. But the second group, which is going to have a subtraction in front of it, everything's going to change sign if you multiply or apply that subtraction sign to each of those. So that 12y squared becomes a minus 12y squared. That plus 5y, that minus 5y becomes a plus 5y, and that plus 8 becomes a minus 8. Because 12 times negative 1 is minus 12. Negative 5 times negative 1, negative times negative is a positive 5, and negative 1 times positive 8 is negative 8. Now, once you remove those parentheses, now you can combine like terms just like you did with addition. So you've got 9y squared minus 12y squared. 9 minus 12 is negative 3y squareds. You've got plus 8y and plus 5y. 8 plus 5 is positive 13y. And you've got minus 4 and minus 8, which gives you minus 12. Those are all unlike terms, and since you're adding and subtracting, you need like terms, so that's as far as you can go. Okay, now this problem, which we did as an addition problem, the only thing that's changed here is now we put subtraction between the two polynomials. The first fraction polynomial you can just rewrite. There's nothing out in front other than an understood 1, and so you can just drop the parentheses. In the second group, though, you have to change the sign of everything, because minus a positive 1/8 is minus 1/8 x squared, minus a positive is minus 7/8 x, and minus a positive 8 is minus 8. Notice that the sign changed for each term in that second group. Now it's a matter of combining like terms. Okay? We've got positive 3/8 minus 1/8. If we do that off to the side here, we've got 3/8 minus 1/8. 3 minus 1 is 2/8. And if we then reduce that, take out a common factor of 2, that gives us 1/4. Positive 1/4. So we've got here, I'll do it off to the side, 1/4 x squareds. Okay, now we've got for our x terms a minus 4x and a minus 7/8. So we've got minus 4 minus 7/8. Minus 4 minus 7/8. We're going to get that minus 4 in fraction form so that we can build it up and get a common denominator. That gives us a negative 32 minus 7/8, because we now have a common denominator. Negative 32 minus 7 is negative 39/8. So down here, we've got minus 39/8, and the like term there was just an x to the first. Okay, now we've got just our constants left. We've got minus 2/3 and minus 8. So over here on the left-hand side, we've got minus 2/3 minus 8. We're going to put that over 1 to make it a fraction. Need a common denominator, so multiply top and bottom by 3. That gives us negative 2/3 minus 24/3, and negative 24 and minus 2 over 3. Sorry, I flipped the order there, but it's the same thing. Negative 24 minus 2 is negative 26/3. And that will tack on to the end, minus 26/3, and that will be our final answer for our subtraction problem. All right, so let's look at that decimal problem. Okay, first polynomial, just rewrite. You've got 0.4a squared minus 0.6ab plus 1.2b squared. Now you have to distribute that subtraction sign, which is like distributing a minus 1. Okay, so you've got minus 4.3a squared minus 5ab minus 6.3b squared. Now we're going to need to combine like terms. So if we take 0.4a squared and subtract from it 4.3a squareds, we're going to get negative 3.9a squareds. You can do that off to the side or use your calculator. We've got negative 0.6ab minus 5ab is minus 5.6 AB. And then we've got 1.2b squared and minus 6.3b squared. If you combine that, we get minus 5.1b squared. And that's your simplified answer to that polynomial subtraction problem. This is the end of Module 10, Section 5.4 material. You should now complete the homework for Section 5.4 found in My Math Lab. And when you have successfully completed the above homework, proceed to the video for Module 10, Section 5.5.